In this video, we'll examine the critical path method for project scheduling, Chapter 13. In Chapter 13 at Table 13.1, the text provides a list of activities for the Western Hills Shopping Center project. That's the project that's being discussed in Chapter 13. You have the activity description, the immediate predecessor, and the expected activity time. You can see I've laid them out in a table like this. If you don't have this table set up, you should pause the video, take a moment, and set this table up. That way we can move forward. You can see that using Excel to find the critical path in the critical path method involves a couple of steps. We're going to do a forward pass through the activities, their predecessors, and the time for each activity. Then when we're done, we're going to go ahead and do a backward pass from the bottom up. Of course, we'll stop there. Then we'll determine the slack, and those activities with no slack will then become a part of the critical path. The text shows you how to do this manually. You should learn that. You should read through the text and go through that exercise, but it's much quicker, much more accurate if you do it in Excel. And that's what we're going to talk about in this video. So in the forward pass, determining the start time is step 1 and the finish time is step 2. And in the forward pass, we're looking at the earliest start time and the earliest finish time. In the backward pass, we know the finish times because we bring the finish time from the forward pass over. So we begin with the finish time and we work our way back to the latest start time. So we work with finish time first, then calculate start time. Let's go ahead and walk through this. First of all, the earliest start time for an activity with no predecessors is period 0. No predecessors, just go ahead and start. Let me center these up so that you can see them a little bit better. The earliest finish time for all activities on the forward pass is the earliest start time plus the time it takes to complete the activity. It makes sense. Again, B has no predecessor, so the earliest start time for an activity with no predecessor is 0. And the earliest finish time for all activities is the earliest start time plus the activity's duration. And because that's true, we can go ahead and just copy this down. Now, these numbers won't be accurate until we complete these values, but as we complete these values, this column will complete itself until it's reached the end. So activity C is preceded by activity A. So activity C cannot start until activity A is finished. Activity A's finish time is week 5. Activity C begins in week 5. Activity D also preceded by activity A. It starts when A finishes. The same for E, which starts when A finishes. Activity F is preceded by activity E. So F starts when E finishes. G is preceded by activities D and F. Both of them have to be finished before G can start. So we're going to take the maximum of the finish times for activity D, comma, and activity F. And that is going to be the start time for activity G. The same with activity H. Both have to be finished, both B and C. So we'll take the maximum of activity B, comma, activity C, and that becomes the earliest start time for activity H. I is the same way. I is preceded by activities G and H. So we have the maximum of activity G and activity H. And we can see 26 days then is the earliest finish time. Now we're going to need to bring a value over to latest finish time, and there is a little bit of a wrinkle here. We have to bring the largest value, the largest finish time of our possible n nodes. So sometimes a model has 2 or 3 n nodes, sometimes only one. We need to determine how many n nodes this model has. The way you do that is you look in the predecessor column and see which of the activities does not appear. If an activity is not a predecessor for another activity, then it is an end node. When it's done, you're done. No other activities follow it. So we have A, B, C, D, E, F, G, H, no I. So we have only one end node, and that is activity I. So we'll just go ahead and get the earliest finish time for activity I, and that becomes the latest finish time for activity I. And the latest start time for activity I is the latest finish time minus the time it takes to complete the activity. We just work backwards. If we know it's done in 26 days and we know it took 2 days to complete it, then we can reason that it began on the 24th day. Now, to calculate the latest finish time for the remaining activities, we want to look to see what activity they precede. So, activity H, I'm on activity H, it precedes only activity I. That means that activity I could not have started unless activity H finished. And if activity I has started, then H finished, and it finished in the same period. So if activity I started on the 24th day, week, whatever, then that means that activity H must have finished on the 24th week, because activity H precedes activity I. Then, if activity H finished on the 24th day, we know that the finish time minus the amount of time it takes to complete the activity is the start time, so we're in good shape. And that's true all the way up. So I'm just going to copy this all the way up. Again, step 2, like step 2 over here. These won't be right until I get these values in. All right, let's do this again. I am on activity G. I look here, I see that activity G precedes only activity I. So activity G finished, and then activity I started. I'm on activity F. Activity F precedes activity G. So when activity F finished, activity G started, and G started on the 10th day. I'm on activity E. I look over here, activity E precedes only activity F. I look to activity F. That's when activity E finished, because activity F starts when activity E finishes. Activity D precedes only activity G. Activity C precedes only activity H. Activity B precedes, again, only activity H. And activity A precedes activities C, D, and E. So we want to take the minimum of these times, because none of them could have started before activity A was finished. So as soon as the first one started, the earliest start time, it meant that activity A had to be finished then. So equals minimum. Then we'll take the start times for activities E, comma, D, comma, and C. We just see each place where activity A appears, minimum. And there we have our model finishing with activity A starting its latest start time, it's the beginning of the project, and then moving through this way. Now that we've determined our earliest and latest times, we can calculate the slack. And it doesn't matter which two groups you use. I usually use latest finish time and earliest finish time, but you can use latest start time and earliest start time as well. I'll calculate the slack using latest finish time minus earliest finish time, and I'll copy that down. And there's the slack. Now, if slack is 0, then it's critical path. So I'm going to use an if function to look to my left and see if it's equal to 0. If it is equal to 0, then I'm going to go over here and get the activity. Otherwise, I'm going to put in a blank. That way, when I want to know my critical path, I can just look down without making any mistakes and say that my critical path in this exercise is A, E, F, G, and I. That's how you determine the critical path using the critical path method in Excel.